coyote does not catch it. Then the third, if coyote chases roadrunner and does not catch it, then coyote is annoyed. And roadrunner is smart. Now we have to infer whether coyote is annoyed or not. So this is our knowledge base and this is our alpha. Okay, so what is this? This is our knowledge base KB. Okay, and this is what? Alpha. Got the point? So this is the knowledge base in which we are given the statements 1, 2, 3, and 4. So we are given the 4 statements in the knowledge base. Okay, and this is the alpha. So we need to prove that this KB can derive this alpha. So we will prove that whether this alpha can be derived from the knowledge base. So what is the first step into this? First, we need to convert all these facts into the propositional statements. First, we will convert all these facts into the propositional statements. Okay, then we apply the resolution algorithm. So how do we convert? Okay. So we know that we have to check whether coyote is annoyed. Okay, so we will negate this statement first, means coyote is not annoyed, and we will add this negated statement to our knowledge base. Okay, we will negate the alpha. Okay, that means coyote is not annoyed. Okay, we will add this negated statement alpha to the knowledge base. Okay, and we will prove that, okay, all these statements in the knowledge base with this negated statement cannot be true. It means that the original statement coyote is annoyed is going to be true. Right. So that is the procedure we have seen in resolution algorithm. Okay. So this is the, you see the statements, you see the facts, and you see the propositional statements. So this is what the fact we are given. So coyote chases roadrunner, we are representing it by chase. All these are what? Propositional statements, and all these are what? The facts in the. Okay, so if roadrunner is smart, coyote does not catch it. So I can represent it using the propositional logic. Smart stands for roadrunner is smart, and does not catch stands for coyote does not catch it. I can also convert in this same way this statement. If coyote chases roadrunner and does not catch it, then coyote is annoyed. So this is going to be converted into this. Then we have a statement roadrunner is smart, that is represented by this smart. Then we have this alpha that we want to derive whether this alpha can be derived from the knowledge base or not. So I have negated this. So what was the alpha? Alpha was coyote is annoyed, and what is the negation of this coyote is annoyed? This is coyote is not annoyed. So that will be represented by this negation of annoyed. Okay, now I will apply the resolution onto these statements. I will apply the resolution onto these statements and I will see whether I am getting true or false. Okay. So I can represent all these propositional statements into a simplified form. Instead of using a word, I can use a single letter C, S, okay, capital B here, capital A here, so that I can deal it with it conveniently. And I need to convert all these statements into the conjunctive normal form, right? So we have already seen that we are having many inferencing rules which can help us to convert all these statements into the conjunctive normal form. So you know that which are already in conjunctive normal form. So you see this is already in conjunctive normal form, this is already in conjunctive normal form, this is already in conjunctive normal form. And these are the two statements, okay, which are not in CNF form. So I need to convert that into the equivalent CNF form. Okay, so how can I convert all this? So you know that S implies B, we know that P implies Q is equivalent to negation of P or Q. So I apply this rule to remove this implication operation. So it will become S implies negation of B equal to negation of S or negation of B. So that will be my clause and that will be the CNF. Similarly, if I apply this onto this, I will remove this implication and I will get this. So this is also in CNF form. This is one clause, this is another clause. Okay, so this is already in CNF form. And we were having earlier expressions like C, S, and negation of A. So I will get all these propositional statements in CNF form. Okay, so I will get all these. Now you see that all statements are in CNF form. Okay, and I need to apply now the resolution. Okay, and I have told you what is the resolution inference rule. So if you have two clause, okay, and you find that in one clause you have some propositional letter A and in another clause you have propositional letter negation of A, so they will cancel out. Okay, and we will get a new clause which is basically a logical OR of both the clauses. Okay, this is the meaning. The C stands for coyote chases roadrunner. S stands for roadrunner is smart. B stands for coyote chases roadrunner. Okay, like that. So we will apply now the resolution. You see here. So we are numbering all these statements 1, 2, 3, 4, 5. Okay. So from 1 and 3, 1 is C and 3 is negation of C or B or A. So when we take all these two, we know that C and negation of C is there. So they will cancel out. And what we will get? We will get B negation of B logical or A. Okay, and this I am calling it expression number 6. Right. Similarly, I can do what? I can see another. So if I take 2 and 4, so if I take this 2 and 4, we know that negation of S is there and S is there. So they will cancel out and I will get only negation of B. Right. Similarly, I can take 6 and 7. Okay, if I take 6, B or A, and 7 is negation of B. So from this 6 and 7, this B and negation B will cancel out, and I will get only A. Okay. Now when I take this 5 and 8, 8 is what? A. 8 is what? A. And what is 5? 5 is what? Negation of A. So when I take this A and negation of A, okay, so what will happen? They will cancel out. Okay, they will cancel out, and I will get a empty clause. I will get a empty clause. Okay, so I will get a empty clause. It means I will get a false. So in case of the empty clause, we say that we are getting a false value. Okay, it means that the contradiction is there. It means that whatever we have assumed that coyote is not annoyed, it is going to be false. It means that coyote is annoyed is going to be true. Got the point? Yes. Yes. Any question into this? Yes. Any question into this? Yes. Any doubt with this? So we are getting a false. You know that A and negation of A, and we are taking a logical and negation of annoyed and annoyed. This is always going to be false. Okay. False means ultimately from all these statements we are getting a false. It means we are getting a contradiction. It means that whatever we assumed is not going to be false, and we have assumed that the coyote is not annoyed. That coyote is not annoyed is going to be false. It means that coyote is annoyed is going to be true, right? So this is the way we prove using the resolution algorithm. Got the point, everybody? Yes. Got the point? Any doubt into this? Is there anyone having any doubt? Yes, Prateek Agrawal is there. Prateek Agrawal. Tell all these guys that I will not be giving them the attendance like this. It is not the case that they just join the class for the attendance and then leave after. I know that how many students are available right now. Yes, Ritik Kumar is there in the class. Ritik Kumar, Naman.
Yes, sir. Present, sir. Yes, sir. Slamish.
Yes. So are you getting the point? Any doubt into this, Ritik? And any doubt into this?
No, sir.
Okay. So we can have another way to prove it, like this. You see here. So from 2 and 3, this is 2 and this is 3. So you know that one is having the negation of B, another is having the B. So they will cancel out, and I will take the logical OR of all others. So this will become negation of S or negation of C or A. So I will get the statement 6 from the statement 2 and 3. Similarly, I get from 4 and 6 this negation of C or A. What is this 4? 4 is S and this is what? 6. So S and negation S, they will cancel out and I will get negation of C or A. Okay. Now I can apply the resolution rule between this 1 and 7. So you will see that C and negation of C will cancel out. Okay. From this 5 and 7, if I use this 5 and 7, or you can use it 1 and 7. So I am using it from 5 and 7. Okay. So 7 is negation of C or A and 5 is negation of A. So negation of A and A, they will cancel out and I will get only negation of C. Now if I apply the resolution onto this 1 and 8, so what I will get? Okay. So when I apply this from 1 and 8, 8 you know is negation of C and 1 is the C. So C and negation of C, they will cancel out and I will get what? False. Right. So when I get the false, it means that the assumption I have taken that coyote is annoyed is going to be false. It means that coyote is annoyed is going to be true. Right. So you can have different ways. You can take different. You can consider these statements in a different ways, and you can prove that the statement can be derived from this knowledge base or not. So if the statement is going to be derived from the given knowledge base, it means that the new statement is going to be added to the existing knowledge base, and that's how the logical agent can create new knowledge using the existing knowledge. That is fine, everybody? Yes, any question onto this? Yes, any question onto this? Yes, is there any question from anyone? Any doubt into this?
No, sir.
Okay, so we move ahead. Okay, so what we are getting from the first case, we got that annoyed and not annoyed, and you know that annoyed and not annoyed cannot be true. So adding this not annoyed causes a contradiction in the knowledge base, and that's why we conclude that the added assumption was false. It means the coyote is not annoyed is going to be true. Right. It means that knowledge base can derive that coyote is annoyed. And this coyote is annoyed is going to be added to the existing knowledge base. Okay. So what is the problem with this resolution? It can take a lot of time depending upon the number of clauses in the knowledge base. So if you are having a large knowledge base and number of clauses in your knowledge base, they are going to be very large. In that case, this resolution algorithm can take a lot of time. Okay, so we take up another example. So what is this example? We are given this B or A. We are given this negation of C or A. We are given negation of B or A. We are given C or negation of D, and we are given this. So all these facts are given into what? In knowledge base. right? So we want to check whether this A can be derived from this knowledge base, right? Now we will negate this A, okay, and we will add this negated A to the knowledge base, and if we find a contradiction like earlier, we will say that A is going to be true, right? So how we can do it? We do the same, okay. So you see that this is our knowledge base and this is what? Alpha. So we want to derive whether this alpha can be obtained from this knowledge base. So we have added the negated A, okay, and we will check using the resolution. Okay, so we apply the resolution. Okay, so you see that this is one, this is another, this is another, this is another, this is another, this is another. All these are the other propositional statements. So if I take this B or A and negation of B or A, and I apply the resolution rule, so this B and negation of B will cancel out and I will get A or A. Okay, and we know that A or A, okay, it is always going to be equal to A. This is equivalent to A, and here I am given negation of A. So when we take this negation of A and A together, I will get a false. You know that A and negation of A is going to be false. So it is going to be false, and that's why I will get a contradiction. Since I am getting a contradiction, so my assumption was actually false. My assumption was negation of A is true. So my assumption was negation of A is true is going to be false. It means that negation of A is going to be false. It means that A is going to be true. So I derive that this knowledge base can derive this fact A. Got the point, everybody? Are you getting the point? How do we apply this resolution? Yes, all of you are getting the point. How do we apply this resolution?
Yes, sir.
Okay, so resolution is simple. Okay, the only thing sometimes you require, you need to convert the statements into the CNF. And luckily in this example, you will see that all these are the clauses. All these are already the clauses. So we need not to convert them into the CNF because they are already in CNF. Right? Okay, so this is actually called the resolution method of inferencing. Okay, so this is the another way to do the same thing. You can have different ways. So you see that this is the given thing. Okay, and from 2 and 6, 2 and 6, A will cancel out and we will get only negation C, that we call statement number 7. Similarly from 4 and 7, from 4 and 7, okay, C and negation C will cancel out and we will get only negation D, that we call statement number A. Similarly from 5 and 8, this is 5, okay, and this is what 8. So D will cancel out and we will get negation of A or negation of B. Now from 1 and 6, 1 and 6, this A will cancel out and we will get only B. From 9 and 10, we will get negation of A. From 3 and 11, we will get negation of B. And at the last, you see that from the statement number 10 and 12, we get B and negation of B, and that is going to be false all the time. So that's why we will get a contradiction. Okay. So in any order, you can consider all these statements. Okay. And if we are getting a contradiction, it means that we can derive the alpha from the given knowledge base. So this is all about this resolution algorithm. So if you have any doubt, you can see onto the screen. Okay, you can tell me where you are not able to understand all these concepts. So I give you 2-3 minutes to see, okay, and analyze what is happening in this case. Okay.
हेलो
Yes. Yes.
सर,
Yes.
एक क्वेश्चन करने के वे हो सकते हैं, जैसे आपने फर्स्ट वाला वे किया था कि आपने फर्स्ट और थर्ड को किया और फिर जो उसका रिजल्ट है उसको आपने सिक्स से कंबाइन करके डायरेक्ट दिखा दिया।
Yes.
तो सर ये क्वेश्चन तो कितने भी वेज में हो सकता है ना?
No, it depends. Okay, it depends what way you do it. Okay. So what happens? Okay, you see that in this case we are getting the result here, but if you follow this, we are getting the result here.
यस सर।
Okay, so it depends. Okay, both are correct. They both are correct. It depends upon you, the way you are actually going to tackle the problem. Okay, the order does not.
अगर हम आंसर लिखेंगे तो आंसर दोनों ही सही होंगे।
Yeah, both are correct. Both are correct. In
कि
the
हम पाथ
yeah,
निकालें।
yeah, it does not matter. In this first case, you see that you are getting the answer okay quickly. In the second case, okay, if you see that you are getting the answer after a lot of computation.
यस सर।
That is the only difference, but both are correct. Both are correct. In both the cases, you are getting a contradiction. So whenever you are getting a contradiction, you will stop. You will stop the procedure. Got the point?
यस सर।
Yeah. Yes. Any other doubt into this? Please see carefully. So it means when you apply the resolution algorithm, okay, many students may apply the same algorithm in a different way, right? So you can choose 2 and 6 first, somebody may choose the 4 and 7 first. Okay, it depends upon you, the way you tackle the problem. So why we are getting a contradiction at the last from the statement number 10, from the statement number 10 and from the statement number 12. So we are getting a contradiction. So is there anyone in the class? Tell me why we are getting a contradiction.
Sir, because in statement number 10, the expression is simply B.
Yes, yes,
In statement number 12, the expression is not B. So
yes.
when I add the both results, the answer of one statement is negative and one is positive, though it cancel out each other. So that's why it's a contradiction.
So basically when we combine this 10 and 12, this is going to be what? B and logical and negation of B, right? B and negation B. And you know that B and negation B is always going to be false. irrespective of the value of B, this B and negation B is always going to be false. So it means that we are getting a contradiction. They both cannot be true at the same time. B and negation B, they both cannot be true at the same time. So that's why we are getting a contradiction. So if B is true, then negation B is false. If negation B is true, then B is false. So it means that both this B and negation B, they cannot be true at the same time. It means that B and negation B is always going to be false. So that's why we are getting a contradiction. Got the point, everybody? Clear?
Yes, sir.
So we want that statement number 10 and 12 both should be true simultaneously. And you know that statement number 10 says that B is true and statement number 12 says negation B is true. So B and negation B, they cannot be true simultaneously. Okay, and that's why it is a contradiction. That's why it is a contradiction. So whenever we get a contradiction in this resolution method, okay, we stop the procedure and we declare that uh, whatever assumption we have taken is going to be false. It means the assumption we have taken, okay, is going to be false, and the negation of that assumption is going to be true. So you know that in this example we have assumed A, we were given A, and we find that we are getting a contradiction. That's why negation of A is going to be false. It means that A is going to be true. So it means that A can be derived from the null case. A can be derived from the null case. So this is the way the resolution algorithm is going to work. Any doubt into this, anybody? Yes, is there any doubt? Okay, no doubt. So resolution will always find a proof if there one exists. Okay, and you can keep going until you have no more classes to be resolved or you get the contradiction. And the speed of the resolution algorithm will depend upon the order of the clauses you are considering. So sometimes you see that if you change the order of the consideration of all these classes, you get the result quickly, right? So it depends, okay, in what order you are going to consider all these clauses. So speed of the resolution algorithm will depend upon the order of clauses. Okay, and there is no way through which we can know earlier that this should be the order through which we are getting the maximum efficiency of the algorithm, right? Other characteristics of the resolution: resolution is sound. Okay, so it means that whatever uh, new knowledge we are deriving from the existing knowledge using this resolution method, okay, it is always going to be true. Resolution is always complete. Okay, so whatever new knowledge we can derive, whatever new facts we can derive using the existing knowledge base, resolution can derive all these facts. So it provided a complete search method. Okay, it is basically a method through which we can derive all the new facts from the existing knowledge. Okay, resolution is exponential. Okay, sometime you will see that the number of classes that we are going to search when we are solving a method, solving the question using this resolution, they are actually growing exponentially. Okay, so these are the characteristics of the resolution algorithm. Okay. Yes. So if you have any question, you can ask me your questions. So in the next class, we will focus on the forward chaining and backward chaining method, which are the other methods which apply the rules of inference. Okay. And that's why we will complete all the proofing methods in this propositional logic.